Just tidying up stuff from my last video, because I've always... Why every time I try and make the desk tidy, things just become messy again. I'm just a messy person. Anyway, hello again, YouTube. This is a light bulb, but it's a broken light bulb. It's quite an interesting thing. It's a Boklod. Anyway, it's a light sensitive LED light bulb. So it comes on when it's dark and it turns off when it's light. And it doesn't at the moment. I'm quite intrigued to take this apart anyway, because it's quite an interesting concept. So I do think how they're doing this, because if you have a light sensor in here like an LDR, it's going to detect the light that this emits as daylight and then turn off again, and then it will detect darkness, and you'd get the cycling pattern. So what I think is happening, I think there's going to be a micro in here, and it turns itself off for just a millisecond or two, checks the ambient light conditions, and then see if it's light or dark, and then keeps the lamp on and off. That's what I think it does. What I'll do, I'll plug it in, and you can see what this bulb does at the moment, which is quite annoying. So the light is plugged in the power. Let's give it some darkness. And you can see it's flickering. It's not on, is it? It's just flickering. It's glowing. I mean, on the camera, it's looking better than it is in real life. Because in real life, it's very dim glow. That's making it look brighter than it is. And what you'll see is it will flicker and do some weird stuff. So yeah, that's it. Should be a lot brighter than that. And it does flicker. You can sort of see it there. You can see it flickering, doing crazy stuff. So I wonder if their power supply and the lamp's gone or something. But we'll have a look. Let's turn the power back on. And now it's all washed out, and you can't tell if it's on or off. It should be off, but you can't tell. So let's crack it open. And to do that, let's balance the phone precariously there so you can see what I'm doing. I'm just going to... I bet if I... Ah, there we go. Ooh, hello. What have we got? So what have we got? We have got... Something's biting my foot. A little board sitting on it. Some very crusty solder joints. A little connector. Is that a right angle connector going on? That is a right angle connector going on. That's probably a little photo transistor or something. Intriguing. Do we have any numbers on these things? Can we see numbers? I'm just looking at the side. There is no numbers. Oh yeah, there is numbers. Oh, bugger. Nearly dropped it. I'll put it in there. Right. Zoom in closer. Let me do that. Do that. Is this helping? Is this working? Oh yeah, look at that. There's numbers. There we go. LM358S. That chip there has not got a number. I reckon that's a micro that they've rubbed the numbers off, because they're bastards. That one there. 7550. That's going to be a linear voltage regulator. And some transistors, Q1, Q2, etc, etc. So op amp probably going to be comparing the voltage coming out of the photo transistor with a set level, something like that, and then that micro maybe doing the flashy thing. But I reckon this is going to be a power supply issue. So got a little pad there. V plus, V minus, V out. How intriguing. Well, let's see if we take this board out, and because I reckon that's going to be fine, if I'm honest with you. I reckon it's going to be the power supply. So power supply comes up from there onto them two wires there. And the V plus. They look a bit crusty, don't they? So much it says a simple case that needs to reflow them. Anyway, I'm rambling now. Let's power this up and measure voltages, especially that voltage there. I've just discovered something quite interesting. So I put it on this lamp, and you can see the lights are flickering. And if I get a torch, here's a torch, I shine it at the bulb. That's not doing it anymore. It went absolutely ballistic on me a second ago, like it's blinding me. but now it's not. Interesting. Oh well. Right, I'll carry on and I'll measure the voltages. How do I turn my torch off? Right. So, yeah, it's now not on. Anyway, I'm going to measure the voltages on the wires that were hidden. Oh, look, it's come back on again. There. Let's measure them. Right, it's now going at full brightness. Sorry for the strobing. All I did was poke an LED and it's next. Oh, okay, there you go. Right, sorry for all the flashing lights, but oh, stop it! The voltage on the power supply is 70 volts, which is kind of what you would expect. There's a 6-volt drop across each LED when they're at full brightness. When they're not at full brightness, it's about 2 or 3 volts. But it's not from the supply isn't changing, so it must be this little trigger board thingy here that's doing that. Let's measure some more. So this is the little control board. I've just taken it out, and you've got on the back here you've got plus, minus, and a V out. On here you've got plus, minus, and V out, and if you look at the tracking, you can see plus goes all the way across to this LED and around to V out, and then you've got V minus. So if you short out V out to V minus on this connector or this pad here, it should be on all the time. So we'll do that. This will then be a normal bulb, and then we can prove that the fault must be on this bit. If this still flickers, it's the fault was in the power supply. That will just doubly confirm it then. I suspect it will be on this board, even though I said it probably isn't. And we can go from there. So put a quick short on there, and this should just be a normal bulb then. And there you go. With that link shorted out, this bulb is on all the time. So no flickering. So it must be this little dude. So this is going to be tricky because of course there's lots of little tracks and it's all white, which will make reverse engineering a bit trickier. Right, okay then. Let's just have a quick look for bad solder joints first and we'll go from there. Right, so a little time has passed and I've done a bit of reverse engineering and a little bit of measuring all these wires and stuff. I think I found what's wrong. So if you look at the circuit and this little thing here, so I'll put that in the middle. Bing! So this is roughly how the circuit looks. So you've got this chip here, which is this chip there. This is just a dual op amp. They're only using one side of the op amp. So on the input of the op amp, you've got a potential divider and a resistor and the photodiode, which is varying the input voltage, and that gives you a on-off voltage for, or signal for the ambient lighting. And then it goes to this micro, which is unbranded, no part number. So you've got input pin, and then you've got an out which goes to a MOSFET that goes to the LEDs. Now, what I think is happening, because the reason you've got micro here is it turns the LEDs off briefly, if you've got like a couple of milliseconds, takes a reading, so there's no ambient light around. Is it light or dark? And then it puts the light back on if it's dark, but the light keeps the light off if it's light, etc, etc. So there's a very slight flicker with this, but you don't really notice it. Well, what I think is happening is I think this FET here has gone. So I've taken the FET off, I'll put some wire links on because I haven't got a small FET. I have one of these FETs. This is a blurb number from RS. 200 volt, 10 amp FET, massively overkill, but it's got a turn on voltage of about 1 to 2 volts. So that should be perfect. So we'll put it in there and we'll see if that works. So a little bit of wiring is required. And here's the Frankenstein bulb now with its MOSFET hanging out. And it's still not working. So if we look at the LEDs, they are currently off. So it's detecting it's off and the micro is detecting it's off. And then when you turn it on, just show it, you see it's doing its flickering business again. And again, if you force the MOSFET on by just holding the gate up, it does turn on at full brightness. So the MOSFET's working. It is clearly the micro, because the micro is getting the light signal. That's absolutely fine. This, as you can see what I've written here, is pulsing. So the output of the micro is pulsing. All the joints of the micro look fine. I don't know what micro it is. So there's two options. Either we get a new bulb, that's the cheapest and easiest option, or we try and find a micro that fits and program it and do that, and that's a lot of work, or we just short it out and we have a normal bulb. Many options. Yeah, but anyway, this board here ain't going to work because the micro's knackered and we don't know what the micro is. So for now, I will leave it there, I think, because there's nothing more we can do. And if I shine a light on it again, you can see the lights turn off. So it does work, just that the microcontroller isn't sending out the correct signals. That was getting really bright as well earlier, so it's just not man enough. I don't know. It's just, yeah. Oh, there you go. See, you just saw the flash then. So it is working, but it's not working. But you know what I mean. Anyway, that's it for now. I'll leave it there. So I'll see you later. Bye for now. Right, I haven't given up on this. So it's a few days later, and I've had a think, and I've checked the power supply and everything. It's all fine. And what I found is over here, I'm going to use a metal screwdriver on a live circuit board, which is nice. This here is where an LED used to be. This LED was going open circuit, but it was still lighting. So when it was working, it was measuring a 6-volt drop, and when the light started flickering, there's a 35-volt drop on this LED. So I've cut it out because I couldn't desolder it because it was too much of a thermal sink. Put a wire link in, and it now works. So if I get my bit of heat shrink, put it over the sensor, bing, it's on. Off. On. Off. And there we go. So our light bulb is working. So all I've got to do now is glue it together, make this MOSFET floating in the air tidy, and glue that down the circuit board, and then we're done. So that's it for now. I'll do it all off video because it's just gluing stuff. So yeah, thanks for watching, and now I'll see you again next time. Bye for now.